As we have dealt with the two very important quantities related to electricity, electric current and potential difference, these two quantities form the foundation of electricity in physics. Now the question is, do these two functions work separately or is there a relationship between them? The definition says that the two quantities are individually different. But a German physicist named George Ohm learned from his experiment that there is a relation between electric current and potential difference. Ohm states that if physical conditions such as temperature, length, etc. are constant, then in an electric circuit, the electric current flowing in a metallic wire is directly proportional to the potential difference applied across its ends. So the question arises, in what ratio electric current increases and decreases then? Ohm named this ratio as resistance. But what is this resistance? Do you remember that water tank analogy from the last video? Here we use that analogy to understand this concept. If a valve is placed in a pipeline which controls the amount of water flowing towards the tap, then this valve acts as a resistance in the pipeline. Resistance literally means resisting anything. Here the one which resists is known as resistor. Here this valve resists water and control its flow. If this valve is replaced with a resistor in the circuit, then we can see that the resistor will increase or decrease the current in the circuit. Now you must be wondering what the resistor looks like. Everything in the circuit that changes the value of the current can be a resistor. Bulb, LEDs or any special kind of wire can be resistor. According to Ohm's law, it can be said that the value of potential difference in circuit is equal to the product of values of the electric current and resistance of the conductor. The relation was discovered by Ohm, so the SI unit of resistance is named as Ohm and is represented by the Greek letter Ohm. If the potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohm. That is 1 ohm is equal to 1 volt upon 1 ampere. Now let's perform an activity to prove Ohm's law. To perform this activity, we need 4 1.5 volt batteries, an ammeter, a voltmeter and a half meter long nichrome wire that will act like a resistor here, and a switch hand copper wires to connect the circuit. Nichrome is an alloy of nickel, chromium, iron and manganese. Connect the circuit in this fashion. We know that the ammeter connected in series and voltmeter in parallel. After the circuit is complete, put on the switch and write down the readings of ammeter and voltmeter in the table. One thing to note here is that wires in the circuit also have little resistance, and also the potential difference between the terminals of the battery keeps decreasing over time. But here to explain Ohm's law, the potential difference of the battery and the reading of the voltmeter are taken equal. Do the same process 4 times and increase one battery each time in the circuit. If the ratio of potential difference and electric current is taken, they will always be the same. So we can say that the rule given by Ohm between the current and potential difference was correct. What will happen if the nichrome wire is replaced by another resistance, say an LED light? Will the ratio still be the same as it was in the case of a nichrome wire? Let's try this. Here the value of electric current has changed due to LED light. So through both these activities, we can say that the value of resistance changes when resistor gets changed. So it would be fair to say that the resistance will be constant until the resistor is replaced by another one. Besides the material and physical appearance of the resistor, resistance depends on other factors as well. We'll understand those factors in our next video.